Hi all, welcome to lesson 2, simplifying radicals. I want you to pause the video for the warm-up and try it on your own. Okay, so let's see, what are we doing here? We're simplifying these. You learned these properties of exponents on day 1. So lesson 1 has all of them. And what we're trying to do here is it's division and your bases are same. So what do? You subtract your exponents. So I'm going to rewrite the work, what I'm doing. You necessarily can skip that step, but I just want to show. So it'll be x to the negative 1 minus 2, and then y to the 2 second minus negative 4, right? If we simplify it, minus 1, negative 1 minus 2 is x to the negative 3, and then you have y to the 6th. You cannot have negative exponents, so what do? You flip it, flip the base. So what does it do? It'll be y to the 6th over x cubed. Number 2, we're simplifying this expression also. So if you look at the negative 1, it's raised to the whole thing. So what do? You're going to raise the coefficient to the exponent and then multiply the exponents. So I'm going to just do these arrows so you it makes sense to you. So let's multiply the exponents. So x to the 2 times negative 1 is negative 2, y to the negative 2, and 3 to the negative 1. You cannot have negative exponents, so what are we going to do? We're going to flip the bases. So if it's in the numerator with the negative exponent, it goes in the denominator. If it's in the denominator with the negative exponent, it goes in the numerator. So it will be 3 over x squared y. So let's get started with the properties of radicals. I'll highly recommend you make flashcards for these properties and get very thorough with it because we will be using them throughout the year. Okay, so it says let a and b be real numbers, variables or algebraic expressions, and let m and n be positive integers. So let's first talk about what real numbers are. Any number that can be written as a fraction is a real number, and your integers are your positive and negative numbers, right? So I have made up already 2 columns and everything is filled in. The properties are there and there's an example attached to it. So I'm going to start with the first one. First of all, let's identify each part of it. When I'm writing a radical, right, this part, the number that goes in this part is called the root, and it's the index, or the index, you can just say that's the index or the root, right? This is your base, and if you write something over here, that's called the power, right? So that's what it is, like you should understand. So here, if I look at my property, the first property, a is my base, m is my power, and n is my root or my index, so that you understand what belongs what and where. Okay, so you should be able to, if you have the power, you can write the power outside also. It's the same thing, it's interchangeable. Okay, and there's an example attached to it. I want to actually pay attention to number 2. I want to talk more about it. So it's the bth root of x to the a, right? So remember, this is your power and this is your power. I'm going to write it again, and this is your root. So whenever you're converting a radical into a fractional exponent or a rational exponent, you write it as a power over root. Okay, so these are interchangeable. You should be able to go back and forth. 5 to the 2/3 can be written. The 2 will become the power. That's your power, and that's your root, which goes in the index of the radical. Okay, so here I already put the dot. The next one, you can separate them when they are in multiplication, only multiplication and division, okay? Not addition and subtraction. It's not true for addition and subtraction. You can write it as 2 separate radicals. Okay, so the next page, don't copy that, we'll talk about it. I also wanted to actually highlight the fact that if you have a square root of any number, let's say square root of a, If I was to write it as a rational exponent, it is a to the 1/2 power. We should be able to go back and forth with this. We should know this. And look here, and I'll explain why. The power here is 1. The index here is actually 2. We don't really write it. Just like when you have the invisible 1 in front of the x, we don't really write this, but it's understood that the square root means the index is 2. Okay, so now if you have multiple radicals, it can be isolated into one, and the indexes get multiplied. And here the last one, if your root and your power are the same, they cancel out. So let's get started with the examples. Before I even start with the examples, I just wanted to, if you see, I made up two lists of perfect squares and perfect cubes. Perfect squares are not the same. If you multiply a number by itself, it's a perfect square, right? So I wrote the first 10, and perfect cubes, I wrote the first 6. If you multiply the number thrice by itself, you get a perfect cube, right? So we would need them to solve these questions. So here it says, to simplify, reduce a radical expression, factor out the greatest perfect power. So when it says greatest perfect power, I'm basically looking at my index. What's in my index? Here it is square, right? Here it's square. If you look at C and D, C it's cube, D it's the fourth root. And we're going to skip letter E, so you can just cross that out for now. Okay. So I'm going to start with letter A, and this number -3, it really doesn't, I don't need to do anything with it till I simplify my radicand. So what do I need to do? How do I simplify it? If you look at 24, and I'm going to look at my perfect squares because we're dealing with square roots here, right? So 24 did not make the list up here, but I want to rewrite 24 as a product of two numbers. One of them is a perfect square. So think about it. If a number isn't, literally go to half of it. Is 12 a perfect square? Check your list. No, 12 is not in your blue list there. So check all the numbers below 12 that go into 24. And 9 doesn't, but 4 does. So can I rewrite it as 4 times 6? Now, how do I check if my variables are perfect squares or perfect power? You look at the index. Here, my index is 2, and look at my power. It's 4. So it has to be a multiple of your power. 4 is a multiple, so you don't need to break it. You just leave it as r to the 4th, right? So this is how you simplify it. That's your first step. Now what you're going to do, whatever is a perfect square, you're going to pull it out. So I'm going to bring down the -3. Square root of 4 is, it's all multiplication, remember. 2. And then 6 is not a perfect square, so the non-perfect ones go under the radical. And r to the 4th, square root of r to the 4th will be basically you're dividing your power by the index. So 4 divided by 2 is 2. So it is 2. So this would be -6 r square rad 6. And that is your final answer. Okay? So I would say pause the video and try B because it's very similar to A. Okay guys, so my 1/3, I don't know, I got these dots here. So my 1/3, I'm going to rewrite it as it is. Now 18 is not a perfect square. So again, think of one of these numbers from the list that goes into 18. Or you can think of it as, if 18 isn't, you literally go to half of that number. What's half of 18? 9. And check, is 9 a perfect square? Yes, 9 is. So 9 times what gives you 18? 9 times 2, right? And now look at this. This power is 5. Does 2 go into 5? No. So what is the number that 2 goes into? Can I break it down into 4 times y to the first? Right? And now whatever are our perfect squares, we're going to pull them out. So it's going to be 1/3. Remember, it's multiplication. Square root of 9 is 3. 2 is a non-perfect square, so it stays under the radical. Y to the 4th will become y square, and y to the 1st, it is a non-perfect, so that stays under the radical. You don't have to write y to the 1st, you can leave it as y, but I'm just doing it so that we understand what did we do. We're not changing the question, we just broke down y to the 5th as y to the 4th times y, right? Simplify this. So 1/3 times 3 is just 1, right? So it's 1 y square and 2y. Let us see. So now look at this. This is cube roots. So when we are working with cube roots, we need to look at our perfect cubes for the numbers, right? We already have a list of them, and 16 did not make my list of perfect cubes. So I need to go to half of it and see whether that number goes into 16. So half of 16 is 8, and 8 is a perfect cube, right? 2 cube is 8. So, oops. So I'm going to rewrite this as cube root. I would say when you're writing the root, please make it smaller than the other number so it's easier for you to identify. This would be 8 times 2, right? Now to look at the power of the variable must be a multiple of the root or the index. So if this is x to the 10th, I'm going to highlight these so we understand these better, right? And my root is 3. So this should be the multiple of 3. Is 10 a multiple of 3? No, it is not. Okay, but can I break it down? Yes, I can. I can break it down into x to the 9th times x to the 1st, right? And if your power is smaller than the index or the root, just leave it as it is. 2 is smaller than 3. I can't really break it down because it won't go into it. So now how do I simplify it? Just like we did for a and b. What's cube root of 8? It's 2. 2 is a non-perfect cube, so it stays under. Cube root of 9, or think about it as you're dividing the power divided by the root. So 9 divided by 3 is 3. So x to the 3rd. And x to the 1st is non-perfect cube, and so is y square. So this is my final answer. I'm going to rewrite it a little nicely. This is 2x cubed, because that looks like really separate, and cube root of 2xy square. So before I start D, I actually wrote the powers of 4. So 1 to the 4th power is 1. 1 to actually any power is just 1. We should all know that, right? Try to remember that. 2 to the 4th is 16. 3 to the 4th is 81. And 4 to the 4th is 256, and so on. And you can find those. You can use the calculator. You don't have to memorize them, but it's good practice that you know what you know a first few. Not all of them, but first few, of course. So now what do I do? Again, it's same when you're breaking them down. The coefficient 2/3 really doesn't matter. We're checking if they are perfect 4th roots, then we're good. If they're not, then we need to break it down. So 162. If you look at this list here, 162 is not in my list. So I'm going to go to half of it. What's half of 162? 81. You can check 162 divided by 2, which is 81. So 81 is in there. Oops. I'm not sure what happened. So I can break this down into 81 times 2. Now look at my root. My root is 4. So I want to make sure these powers are either 4 or are multiples of 4, right? So is 8 a multiple of 4? Yes. So I don't need to break it down. So I'm going to keep it as it is. Y to the 3rd. If you have a power smaller than the index, you just leave it like that. You don't really have to do anything. Now 14, z to the 14th. 4 does not go into 14th. What's the closest number to 14 that 4 goes into? It is 12. So if it's 12, how many z's am I left with? 2, right? So that's what you do. So now once it's broken down, all you have to do is take the fourth root, simplify it a little, and you're done. So 2/3. Fourth root of 81 is what? What number did I multiply? It's 3. Yes. And I'm going to set up my non-perfect ones. 2 is a non-perfect one. X to the 8th. Fourth root of x to the 8th would be you just take your power divided by your root. So 8 divided by 4 is 2. Y cube, it stays under. 12 divided by 4 is 3. And z square stays under. Now let's simplify this. This is all multiplication, remember. Okay? So the 3's actually cancel out. So you have 2x squared, z cube, and fourth root of 2y cube. I'm going to do 2 questions from the practice problems, numbers 1 and 8, and the rest of them, please try them on your own and check your answers with my answer key. So let's get started with number 1. This is negative, there's a 1 in there. So this is -1 radical. Again, please copy your list of perfect squares and cubes from the last page, or you can just write it on your own. 12 is not a perfect square, so find me 2 numbers, one of them is a perfect square, goes into 12. So it's going to be 4 times 3, right? Now look at your index or your root. It is what? 2 here. This is 2. So to look at the powers, they should be multiples of 2, right? So is 10 a multiple of 2? Yes, 2 goes into 10, so I don't need to break it, so I'm going to leave it as m to the 10th. Now, just simplify further. Take the square root of the perfect squares, so square root of 4 is 2. 3 is a non-perfect square, so it stays under the radical. M to the 10th. All you're doing is dividing power by root. Your power is 10 divided by root, which is 2. So 10 divided by 2 is 5. So it's m to the 5th. Simplify this part. -1 times 2 is -2. M to the 5th. Rad 3. Number 8. So for number 8, I'm going to rewrite it as I'm going to separate the radical in the numerator and the denominator. There's a 1 again here. So it's -1 rad x cubed over radical 32. Right? So let's simplify the numerator first. The -1 just stays out. The index is what? 2, right? And your power is not a multiple of 2. This is 3. 3 is not a multiple of 2, so you're going to break it down. You're going to break it down into x squared times x to the 1st. Similarly, I'm going to do the same thing in the denominator. Radical 32. You can check it on your list. 32 did not make your list. So go to half of 32, which is 16. 16 is a perfect square, so I'm going to break it down into 16 times 2. So now I'm going to take the square root, so it's going to be -1. X squared is just, square root of x squared is just x, and I have radical x over square root of 16 is 4 rad 2. I cannot cancel anything, so that is my final answer.